So thanks everyone for coming along, as always. This is the ITV Technology Forum. There's an opportunity for any of us to get up and talk about whatever it is we think is interesting from a technical perspective. We've got kind of one talk on the agenda today, which is going to be Benny talking about the innards of Scala, the functional programming language that powers a good chunk of online and most of broadcast as well. So Benny, over to you. Thank you.
Yeah, hi everyone. I'd like to talk today about a Scala feature. The aim of the presentation is to discuss the controversial aspect of the feature that have emerged in the Scala community recently and explore one of the alternatives. This presentation does not seek to prescribe any particular solution, rather it hopes to enrich your understanding of the subject. Let's create a simple function with feature. Okay. What can we say about this? Okay, this function returns a feature which gives us the information that there is a running computation. The first important thing to know. This function could return a successful outcome with the content ID or a failure with the reason why the running computation could not finish successfully. Moreover, sometimes when it performs I/O, it could help us to not block the thread during the I/O. This is an important thing. Okay. However, as Bender observes, from a functional programming perspective, we have to ask the following question: is the previous function pure?
What's a pure function?
Well, this is the presentation about. One of the ways to answer that question is if the function is referential transparency. In the case we discover is not referential transparency, we therefore can deduce that it's not a pure function. But yeah, in order to answer your question, a pure function is a mathematical function. Basically, when you receive an input, you always have the same output. This is the main idea behind pure functions. This question raises an important point, as it could help us explain to the function user that this is a function that can produce side effects. Okay? The user can, however, have some control over them. This is the main discussion, basically. Well, a simple reminder of referential transparency. This is a quite common example of referential transparency. I use data now. A function, I remember what is a referential transparency. If we are able to replace some of the expression of the program without affecting the meaning of the program. This is important, because if we are affecting the meaning of the program and we do some refactoring, basically we can see here we are doing some refactoring and we extract data now to a lazy val, then we are changing the meaning of the program. Okay. Then, as we can see, the example data now is not referential transparency. Let's do the same test with future. It's the same scenario. I have only renamed the functions and used the future apply in order to repeat the simple test. In this case, we can observe the result is different. Therefore, we can deduce that the functions with future is not pure, as it produces side effects itself. The type itself is producing side effects. And as you can see, I have only replaced data now, and I have used a feature apply. This is the only change. Here is a good question from Bender. Sometimes the answer is oversimplified, sorry. Sorry. For the Scala developer, a monad it is a functor and has to provide two new methods, unit and bind. Sorry. Unit is the apply function in future. Bind is the flap map in future. Map is in order to implement the functor. Okay. However, do we require something else? This is the case of monad. We are required to implement the following laws: left identity, right identity, and associativity. I'm not going to explain the whole rules, but let's verify the right identity in future to discover if it is a real monad. Okay. Let's create a simple feature. If we execute the effect, we are able to see an effect. However, if we apply the bind to the effect and we apply unit, the result is empty. We can verify that the right identity is broken. We can deduce it is not a monad. Okay, it is not a pure function, and it is not a monad. But could we say anything else about it? One of the main problems from my perspective, apart from the previous issue, is that it is eager. Basically, when you create a feature, it submits to a thread pool. This can saturate the thread pool or waste resources on trivial work that could be executed in the same thread. This is something that, for example, most of the time we create a different execution context in order to execute in the same thread. Another interesting observation is when you flat map, you need to submit it to the thread pool, and context switching takes a bit of time. And finally, it cannot be canceled. Okay. What is my mouse? Sorry.
Hey, who's been messing with the radio? This isn't alternative rock, it's college rock. Oh.
Well, as Bender says, it's something else. My point is, future, where in the community we have using for functional programming perspective, but from my perspective, future is a right abstraction, but it's not from the point of view of functional programming perspective, okay? At least for me, for the reasons that I mentioned before. Okay. Then, if I have to access a database, connecting to a microservice, render HTML, is it possible to do it in a functional programming way? Maybe. Let's have a look at IO monad. Okay, the big idea behind it is instead of performing IO as a side effect, is return a value to the caller that describes how we want to interact with the IO system. Yeah, it's not enough. But IO monad, as we can see, does not implement concurrency, and most of the times we want concurrency, some mechanism to implement concurrency. Let's have a look at task. Yeah. Task is a purely functional description of a possibly parallel computation and grabs the Scala concurrence feature with some functions for handling exceptions. Future is not the standard Scala feature. It's a trampoline computation that produces a result. A trampoline represents a computation that can be stepped through, and it also guaranteed to use constant stack space. I can demonstrate later what I'm trying to say with this sentence. Okay, sorry. Okay, fair enough, Bender. We want to verify that it's referential transparency. Sorry. Okay, this is, let's verify the referential transparency in this example. You can see I didn't use the simple example that I used before. I make it more complex. I use random numbers and all these type of things. Okay. As we can see, it is referential transparency. As we can see, task is lazy, and it is not executed until you decide. From my perspective, it is a good abstraction in order to inform the function user that the computation can produce side effects and then the user can decide what he wants to do with it. For example, he can decide to compose with another functions or execute it. Okay. let's do a simple demo. We are going to try to create a very, very simple puppet. In this case, I call it Pong. The idea is create a script that is going to create a target folder, download 5 files, and set the files in the target folder, and show the results as a tree. Okay, this is the script, but before explaining the whole script, I'm going to enter in the details of tasks, because my main objective with this demo is to explain how it works task. Okay? Let's go to, for example, to make dir. Oh no, sorry. Well, as we can see, it's executing some process. Let's verify execute process. And this is the point that I want to start. Okay. Sometimes we have to integrate with blocking APIs, because most of the time the people think, oh, okay, I want to integrate with no blocking APIs, but sometimes you don't have any other opportunity to not integrate with no blocking. You have to block. Okay. Then I'm going to explain this part of code that, as you can see, is quite imperative, because we have yesterday in the textbook I explained that functional programming is more similar to imperative programming rather to have another thing, because basically in this example I create 2 references. After that I create a task that is going to return a process. This is using the function apply. Apply is the main constructor to create task, and it is lazy. Basically, at this moment, it's not executing anything at all. It's lazy. This is going to be executed when the user decides that it's going to be executed. Basically, we are describing what we want, not how we're going to do it. Basically, it's a description. After that, when we integrate with the blocking part of the code, I explicitly say I want to fork. Basically, I want to create a thread that is going to when the code is going to be executed, is going to create another thread that is going to wait, because I don't want, because you have to think that if you don't explicitly say to task that you want a different thread, it's going to execute all the time in the same thread. It's an interesting thing, because you define when in the points of your code that you want explicitly create a thread. After that, well, I can explain later the time thing, but basically I am finished. I want to destroy the process that I have created in the previous sentence. The most interesting thing I create, well, it could not be atomic in this case, but I create atomic in this case in order to simplify the code. But basically I can create mutable reference in my code, and I can mutate in the I can set I can set at this point the value that I want to set. Then it's an important thing that most of the people think, mutability. If you are doing pure functional programming, you can do mutability. But the important thing is the referential transparency property. This code it has mutability locally, and it not produce side effects. Okay? Sorry, I'm going to explain in a different way. No side effects. Well, it's not creating side effects in the way that is referential transparency, the code. Okay. Let's move to the next thing. Okay, I explained how to integrate with blocking APIs. Okay. Okay, sometimes I want to integrate with no blocking APIs. For no blocking APIs, the task is using callbacks. It's not using any promise or promise pattern. It's using callbacks. Basically, when you create the task asynchronous and you provide the callback, when in this case the framework is providing you another hook to when it's complete, you can call back with the right part, as this is similar to any framework. And if there is an exception, then you call back with the left part. Basically, because task is an either of a result or a throwable. Okay? So, can you understand? Or I see.
Yeah. No,
Okay.
I'm putting a funny face because I'm not quite sure. I've never seen anybody use a callback in Scala.
No, that's not Scala library. It's named async HTTP.
This is Netty. This is Netty.
Fine.
This is Netty.
You can do it.
Well, I try to explain. The main important thing is explain how to do things that we are doing with Scala, because sometimes you have to integrate with blocking and not blocking APIs. And I want to explain how to do it with Task, basically. Okay. One interesting thing is that I like from this framework is the composability thing. It's similar to feature in the way that the code looks, but in this point, you know that you can compose things because it's not running. Then it's more, from my perspective, it's more safe to compose at this point. And if you see, download is like get from a URI and then write to disk. Okay? These bytes, basically. More things. Sorry. Okay. Well, in the presentation, I talk about trampolines. I'm not sure how many people have heard about trampolines before. Okay. Not so many. Well. Okay. Most of the people, I think, they can know how to integrate with tailrec in Scala. That basically, when a function is tailrec, the Java code makes some optimizations around the recursive function, and it can generate basically, you don't have to use the stack in order to execute the function. Basically, it's the same thing, but for non-tailrecs. There is some discussion around the Scala community if this is a feature that should be executed by the compiler. The problem is not implemented in the compiler, then the people implement this pattern that is called trampoline. Trampoline is a simulation of the stack, but you are doing in memory. Basically, instead of using the stack of your program, you are using the memory in order to simulate the stack. Then, in this case, you have a tree that you have multiple nodes. Basically, it's possible, probably Jamie can do a tailrec implementation, but most of the mortals cannot do that. Then, in this case, it's a simple implementation, and we use, in order to use the trampoline, when we execute Go, instead of executing Go without trampolines, I'm using task suspend in order to say to task that this is a recursive function that is going to be executed in memory. Okay, this is quite interesting because sometimes you want to do some cool things, but you can not do it because you are not able to do it in a simple way. One of the problems of trampoline I have tested, I don't know, how many, what do you think is the problem of a trampoline?
Speed.
Yeah, speed sometimes depends, because Speed could be a problem. Actually, there is a way to work around that problem because there are some ways to make optimizations, but and depends on the number of elements. Probably, if you have a small number of elements, probably the speed is better without trampolines. But when you increase the number of elements that you have to iterate, probably trampoline is faster. But what is the other problem?
Memory usage.
Sorry?
Memory usage.
Exactly, memory usage. I have executed one big function for a long time, and it could get you gigs. Depends, not for simple stacks. For simple stacks, maybe you have a stack overflow, but you can execute the trampoline without any problem. Then, if you are using trampolines, one of the main things that you have to control is the memory use. Okay? Yeah. And the final thing is the pump up. After that executed, of course. Okay. Let me know if you cannot see the code. Okay. Can you see the code there, Kevin? Okay. Well, I can.
I don't think it really matters.
Well.
Say anything, Benny.
Okay. Well, this is my program in order to do the thing that I want to execute. That basically, I want to avoid any exception at all at this main program in order to be composable. And then I only want exceptions at this point. At this point is when I'm going to launch the missiles and everything is going to explode. When it's going to execute the effects in the system, okay? But at this moment, this task is pure. There is a guarantee that it's not going to be execute anything. Then, for example, I print some message. I create a target folder I create a temporal folder. I make the dir because maybe the dir does not exist. I create a query function from the target folder in order to create the first zip file and the second zip file. I'm going to download some code from GitHub. Another interesting thing is this. As I told you before, we have the ability to fork and create a different thread. But this is another interesting thing from task. You can decide that I'm going to be non-deterministic. But as always, we explicitly say, I want to be explicitly in the way that at this point is going to be happen something that is not deterministic. In this case, I'm creating two parallel threads that one is going to download the first zip file, and the second is going to download the second one. This is, we are going to download in parallel two zip files, okay, and save to disk. Well, this is one advantage from Puppet. Yeah, I'm joking. Basically, my main concern here is you explicitly say when I want parallelism, and I explicitly say how many elements I want in parallel. Then, if you see in the for compression, I can. It's not an applicative functor, but it's a kind of applicative functor. I'm not going to explain the applicative functor, but I think we have the discussion before, in the way that the flat map is the sequential thing, and all the things that you have in the other order is parallel things. Okay. And after that, I print the tree. Let's see, to explain more things, the last things is one of the things that we can verify from the task is I can say for this task, I want a timeout for 30 seconds or whatever. Then when I say download this URI to that path, I said, okay, I want that it should be downloaded in less than 30 seconds. In this moment, I put a timeout not only in the when I get the things in the from the network, is a timeout for the whole thing, for download, for make a get to the server and to write on the disk. Then I can say, okay, if there is an exception, I want to handle with this thing. Okay, it's a simple way. They have combinators that can provide you simple ways to do things. Okay, and one interesting thing I can say is the unzip. I don't know. I have an unzip function that is very bad, and sometimes breaks all the time. I don't know. It's something that I can guess. I can say, okay, I want to unzip this, and I want to read. If it's failing, I want to retry in 1 second, and if it fails again, in 2 seconds. I think from my point of view, the combinators of tasks are very powerful and very expressive, at least from me. And finally, I'm going to differentiate. One of the advantages of tasks is that you can have different ways to execute your task. One way is, okay, I want an attempt ramp. Attempt ramp is going to return you an either of the exception or the result. Then sometimes we have done this type of helpers in features in order to not throw in an exception. I want to see the result, so I only want to print. I don't want to break my whole system. I can have some control of the exception that is producing in the system. And the other alternative is to run it directly. Okay, that run is like when you create a feature, it's the same that run. No, it's not the same, but it's similar to run. Okay, because as we see, feature when you apply a feature, can contain side effects. And finally, we can do the demo thing. We can remove this. Sorry. And hopefully it's going to work. Okay. Yeah. Run successfully. One of the things that I have here is some verification. We can execute as well. I can run two times. Yesterday I ran 100. Yeah, for this demo I only think with 2 times. And I want to verify that the result of the function is always the same. Because one of the important things for the perspective of tasks is that it's deterministic. We want to have always the same input, always the same output. Well, now it could fail, but yeah. Of course, could be some network problems. But it's not causing anything. Okay? True. Then, as we can see, this program is referential transparency. Okay? And that's all. We can go back. Any question?
So there's one place where you created this thread to parallel processing. I didn't see anywhere you passing in the executive context.
Okay. I didn't do that because one of the ways that task is using Clazy. Clazy in order to inject the execution context, because you can always pass the execution service that is different from the execution context. The task is implementing their own execution context, for your understanding, that is called execution service. You can provide that, but in general, in the Scala set community, they're using Clazy in order to, it's a concept, in order to inject the dependency. They are using a different way to inject the things. And I didn't want to introduce this concept in this meeting now. But basically, any task you can provide the execution context that you want.
Is it at the time when you do the fork, or is it at the time where you do the run?
In the time that, basically, I was thinking about this. This is an interesting question, because most of the time I would like to provide that execution context at runtime. But you have to provide in any task that you want, because you have to explicitly say in which executing service you want to execute that task. But if you're using Clazy, in some way, with Clazy you can say run and then you provide the argument. Because Clazy is like basically it's like it's providing you, instead of returning the task, it's providing you a new type that is Clazy of task. Then when you have to provide the config, it's creating a function basically. And you have to provide the config that you want to run. Basically, it's a different way to inject. I don't want to explain that now, but yeah, I can explain you if you want.
Yeah.
There is apart from that, there is a good website. I can share the link that explains all these things of tasks. It's quite interesting. Yeah. Anything else?
So you got a question, Dave?
Yeah. That's all.
Benny, in your example
Yeah.
of futures, Scala futures being referentially, or not referentially,
Yeah.
you use print line.
Yeah.
Obviously, print line isn't referentially transparent, so if you use it in
But in my task example, I use print.
but if you run that task twice, then you're going to get different results.
I can do the
So
example.
print line twice. So if
The
you
main
use print
difference,
line
I
twice,
saw
you're
you.
going to get print line twice.
I saw you. Yeah. Let's go back. In this example, I can create the code. I think that I have the code basically. If you create a task in any other of these scenarios, it's going to execute always. It's going to execute 2 printouts. If you run the first time and if you run the second time, it's going to execute twice the print line. The problem here is when you execute the first
It won't
time.
execute it until you call run.
Exactly. But
So it
when
just
you
checks
run
how
it,
many times you call run.
you have to run. The only difference is that you have to run here and you have to run here.
Yeah. So if the first time if you run it twice, then you get 2 printouts. That's kind of what I mean.
Yeah.
The print line is just going to print as many times as you execute it. It doesn't matter whether it's task or future or.
No, but the difference is the constructor. Let me try. I don't know if I have the code. Let me show you.
I was just wondering if there was a referential transparency example which didn't use print.
The problem is, I'm going to tell you for something. The problem is future. It could be referential transparency, but in one condition. Which is the condition? That is referential transparency.
Presumably that the inputs are referentially transparent.
It's only referential transparency, or it could be referential transparency only if you are executing pure computation. This is the main difference.
My point is, if it's an impure thing, it's never going to be referential transparent because you can always get different results in wherever you.
No. Well, have you seen my example? I execute 3 times, and all the time it's executing the same
Yeah,
thing.
but unplug the network card and you get a different result.
Yeah, but it's a different. Well, this is a theoretical point of view, but yeah. I can understand you. No. But I can explain you why. Because from the point of view of referential transparency, ideally, you have to what is the parameter that you have to provide to your function? If you want to, for example, for print line, what is the condition or what is the parameter that you have to provide to your function? What is the parameter? Because you cannot have void. Void is not a valid parameter in this case. What is the parameter that you have as an input?
Stands out.
No, well, yeah, the standard out or the real world, basically. You have to provide the real world. Then if the circumstance of the real world change, the results are going to change. Then it's not if I change the state of the system, that is, if I change some parameter of the real world, the result is going to be different. This is a theoretical, I know, but basically, the idea behind is simulate that you provide in some way the real world, because the real world is a parameter of your function. It's like you say, well, I can give you another example. If you have a list of users, then your list of users is not going to be referential transparency. No, because your data state, no, because you have to provide the parameter. The parameter is the database or the table or whatever.
But for the same, exactly the same input, we'll always have exactly the same output.
Exactly.
Vary the input by taking away like the pitch equal.
Exactly. If the condition of my world or my real world change, it's not the same parameter, the same input. Okay, let me check if I can have the example of, actually I have for the presentation, but I removed because I thought that I didn't have time. Well, I can do it here.
Is it in your history if you removed it?
Sorry?
Is it in your history if you removed it?
No, I don't have the example prepared now, but it's simple to do it, I think. Well, if I don't have time, depends.
That would be minor questions.
Or if you want, I can explain you later. I can show you later if you want. Yeah. Any more questions? Or?
Good. Well,
Okay.
thank you very much, Benny.